Hi! So today, in this video, we're going to be talking about chapter 6.3, which is the inverse of a logarithmic function. Now, a lot of you have probably are very familiar with this type of chapter because we've done it for quadratic equations, we've done it for linear equations, and we've done it for exponential equations. And in fact, the inverse of a quadratic equation, the inverse of a logarithmic equation actually turns into an exponential equation. So, basically, when you are graphing the inverse of any graph, you just basically swap the x and y's. It gets a little bit more tricky when it's harder to find like specific points, but the same principles will apply here. If it helps you, you also can graph like a line that's x equals y that cuts across through the origin. Because that is sort of what inverses are as well. You just reflect it over x equals y. Hold on. Okay, yeah. So let's just hop into it. We want to use the graph of f of x equals 2 log base 2 x minus 5 below to graph its inverse function using reflection across the line y equals x. Now, there are lots of different ways to do this. I'm going to just do the swapping the x and y values. It says you can use it reflecting across the line y equals x, but that's exactly the same thing. So we have a point 4, -1, and we have a point 2, -3. So to do that, we just swap their x and y's. So now we have -1, 4, and -3, 2. So, -1, 4, and then -3, 2. And this is not that much information, but like if it was just us graphing. But we know since it's reflecting across the y equals x, it'll look something like this, right? Like kind of like a baseball almost. And that would be your new one. The lumen will graph it with 2 points. You just want to make sure the curve is correct. Next question wants us to determine the inverse function of g of x equals log base 5 to the x. This is going to be using the information that we have learned before of switching from logarithmic form to exponential form. But first and foremost, we have y equals log base 5 to the x. Swap the x and y, so x equals log base 5 to the y. We want to solve for y. To get y by itself, we're going to need to convert from logarithmic form to exponential form, which leaves us with 5 to the x equals y, and that is our new inverse function. So f of the -1 x equals 5x. That's our inverse function of our logarithmic form. The inverse function of g of x equals log 9 of x, it's basically the same thing. Base 9 to the x equals y. There you go. F of -1 x. I don't know why I had two of the almost same ones. This one's a little bit different. Determine the inverse function of g of x equals log base 4 to the x minus 2. And we want to express our answer using inverse function notation. Now, again, we'll switch to x and y. So we'll have x equals log base 4 to the y minus 2. Now, these parentheses are important. If it was outside of the parentheses, what we would have to do would be plussing 2 to both sides. But since it's inside the parentheses, we actually can switch to exponential form already. So we'll have base 4 to the x equals y minus 2. And now we can add 2 to both sides to get y by itself. So we have 4 to the x plus 2. And that's our new answer. F of -1x equals 4x minus 2. 4 to the x minus 2. Determine the inverse function of g of x equals 2 log base 4, x minus 5 plus 5. This one, we're going to, again, swap the x and y. So x equals 2 log base 4, y minus 5 plus 5. We need a minus 5 from both sides first before we change anything. So we have x minus 5 equals 2 log base 4 to the y minus 5. Now we need to divide both sides by 2. It's sort of like pretending this part is an x. The log is an x, or like a z. So now we have 1/2 x minus 5 halves equals log base 4 to the y minus 5. And now we can convert to exponential form because there's no pluses or minuses and there's no multiplication or division. We need it to just be the log. So now what we have is 4, because that's our base, to the exponent, which is 1/2 x minus 5/2. And then equals y minus 5. We can add 5 to both sides, which leaves us with this plus 5 equals y. And this is our new inverse. Determine the inverse function of g of x equals 3 over 7 log base 3 to the x minus 2 plus 4. Again, these parentheses are important. We're going to switch the x and the y. X equals 3 over 7 log base 3 to the x minus 2 plus 4. We need to get rid of this 4 first. It's like if we are pretending this is an x. Let's turn this into a z. Not an x, but like a z in this case. So we're going to minus 4 from both sides. So x equals 3/7. You could put z if you are wanting to, or just log base 3 to the y minus 2 in parentheses. Now we need to get rid of this, so we'll multiply by the reciprocal. This is x minus 4, which will give us 7/3 times x minus 4. Log equals log base 3 to the y minus 2. Now that there's no multiplication or division or addition and subtraction, we can convert back into exponential form, which gives us base 3, because this is a base here, to the 7/3 x minus 28 over 3. I'll write that up more. 28 over 3 equals y minus 2. We can add 2 to both sides, so we get plus 2 equals y. And this is our new equation. Given that f of x equals log 9, x plus 9, and g of x equals 9x minus 9, determine if f and g are inverses. Now, if you remember doing the inverses of, I believe we did it in the exponential, maybe not the exponential, but if we did it in the quadratic and the linear form with 2 different equations where we did the composition of the functions that we are testing to see if they are inverses, how if they are inverses, they will be the same. So for instance, this answer should be exactly the same as this answer. So log base 9 to the g of x, so 9x minus 9 plus 9, that will turn into 9x, and then we can turn this into 9. These 9s will cancel out, so it will turn into x. I guess we'll get into that in a little bit. I don't think we've gotten into that yet. So the exponential form would be base 9 to like the y equals 9x. So x equals y. So this will be x. And then we will do 9 to the log 9 x plus 9 minus 9. And to help with this, we can, hold on. I'm trying to remember if you guys have learned that part. Because this will turn into x. But, so basically, when you have a log base 10, or like 10 to the log base 10, or e to the ln, like x, or 3 to the log base 3, basically where the base is to the exponent of a log with the same base, these are going to cancel out. So you'll be left with x in this case, because ln is log base e, and log base 10 will cancel out with 10, leaving you with x in all of these cases. This is the same case here. These will cross out, leaving you with x plus 9 minus 9, which leaves you with x. I don't remember if we've taught that yet. I'm sure there's a roundabout way to get there by converting into logarithmic form or exponential form. It is a good property to know, and it will make your life a lot easier. But yeah, anyway, they are inverses because they have the same answer. Given that f of x equals log base 2 to the x minus 1, and g of x equals 2 to the x plus 1, determine if f and g are inverses. So this will turn into log base 2 to the 2x plus 1 minus 1. And again, well, hold on. Now what I would maybe do is convert. So we have base 2 to the y equals 2 to the x plus 1 minus 1. Hold on, actually. Oh, wait, I forgot. We don't have to do function composition to find out whether something is inverses or not. The reason why we were doing function composition before is because it was prompting us to do function composition. If function composition is an easier way for you to do things, I recommend doing that. However, in this case, we haven't learned some of the log properties to necessarily do this in an easy manner. So instead what I would do is I would just find the inverse of one of these functions. So for instance, x equals log base 2 to the x minus 1, y minus 1 equals base 2 to the x equals y minus 1, which is the same as 2 to the x minus 1 equals y, and they do not look like they are inverses. Let me double check in here though. Are not. Okay, yeah, these are not inverses because this does not equal this. It's close, but it's not quite there. Anyway, if you have any questions, please let me know and I'll answer as soon as I can. Have a good one.